Good morning, good afternoon, and probably good evening for a few of you. Let me briefly introduce myself to you before starting this presentation in a few minutes. My name is Jongsik Lee, and I'm currently in charge of Infrastructure Transformation R&D Lab, including 5G and its surrounding technologies. I wish I could interact with many of you on this challenging topic in person, but for now and today, I guess we have to settle for this current format. First, I would also like to take this opportunity to thank GTI for allowing me to speak on this emerging topic, while I have to admit in advance that I find myself somewhat new to this field. Today, I share KT's perspectives on network energy saving for carbon-free environment among many approaches to this grand theme of decarbonization. As we are all aware, the World Economic Forum listed decarbonization as one of the top 10 emerging technologies to come in the near future. Indeed, this seems to be gaining more attention as various industries are declaring their commitments to decarbonization. Government is also pushing for strong and more aggressive policies planning to reduce the carbon footprint in any way they can. And 137 countries have expressed commitment to carbon neutrality. Looking at the current situation of Korea, it clearly explains the reason why decarbonization is gaining attention. Korea has also joined in pledging to make the country carbon neutrality 2050, keeping in lockstep with recent global commitments to tackle climate change. Korea is fully committed to take actions on climate change, and the government is pushing for extensive initiatives to shift energy sources. Strong government policy plays a very important role, as we see in this example from USA GHG, or Greenhouse Gas Regulation based on Clean Air Act addressing the carbon emission since 2007. Korea also aims to follow similar steps in future by government-driven policies focusing on carbon emission. Taking its cue from an aggressive government approach, ICT industry is also encouraged to take effective part in this policy. ICT's carbon footprint estimates 1.4% of overall global emissions. In order to effectively reduce the carbon footprint in this industry, all four sectors of user devices, networks, data centers, and operations need to be addressed. So what is being changed in the telecom industry? If we refer to this familiar figure from ITR INT 2020 vision document, we can clearly see that for the first time in wireless communication history, the term network energy efficiency has been included as the key KPI of 5G. KT believes that this is a clear indication to what we are facing today. This means the telecom industry is fully committed to the goal of reaching carbon neutral and net zero. We can even now predict that 6G, which will come in emerging future, is also considering energy efficiency from the very initial stage. Now, let's have a look at how telecommunication industry is working on network energy saving in order to achieve the network energy efficiency KPI shown in the previous slide. Telecommunication operators are working on network equipments, network operations, and cloud and network facilities for the chance of decarbonization. Green-based stations using reusable energy is certainly one of the trends which operators are interested in. Also, reducing power consumption by using power-efficient devices, modules, and parts is being considered as a key enabler of decarbonization. KT is also aligned in the same direction on decarbonization. KT is particularly looking closely into network energy saving in aspects of network equipment and infrastructure. Energy can be further saved from optimizing network operations as well. We also need to consider energy savings from cloud-native infrastructures, which will come in near future. First, let's have a look at network energy saving from infrastructure perspective. Based on KT's actual use cases, extra power consumption can be saved from enhancement of a power amplifier used in a radio unit RU of base station. Power amplifier bias control limits the resource block number to 50% while transmitting downlink data while the mode is active. Also, simple level of power amplifier on and off control in real time helps reducing extra power when downlink traffic is not transmitting any signal. Now, let us look at the network energy saving from the operations perspective. Energy can be saved from cell load and customer behavior. From the antenna side of RU, transmission path on and off controls, on and off status of specific antenna element to reduce unnecessary base station energy consumption. The technology operates based either on a specific time schedule or load factor to maintain quality of service at the edge of a cell. It detects 5G devices and toggles the transmission path from on to off to on. Also, cell on and off turns the cell off during periods or in locations with almost no load to reduce energy consumption. Whenever traffic falls below a certain level, the entire 5G is triggered off. The cell is turned back on whenever LTE statistics indicate that a 5G device is requesting services. So, applying what I have just mentioned above, here are the figures of KT's achievements. Each technology resulted power saving from 13 to 23% reduction of total power. In terms of OPEX, we have saved 6.8 billion Korean won, which approximately amount to $5.7 million in energy cost. Beyond the monetary impact, this is equivalent to removing 26,000 tons of CO2 or about 4 million pine trees needed to offset carbon emissions. Technology's impact surpassed expectations, and considering the growing number of 5G base stations, the power saving impact is expected to further increase. As we have seen from the previous slides, current network energy saving technologies based on infrastructure and operations are mainly focused on the radio unit side of the base station. In addition, telcos also need to consider energy saving from the other areas, especially on IDCs and facilities. As we are witnessing today, the evolution of cloud-native infrastructure is happening globally, and industry is working on reducing carbon footprint in IDCs. Google is utilizing DeepMind's machine learning solution to reduce the energy consumption up to 40% by cooling Google data centers. Meta's new traffic management solution called AutoScale, which can cut the data center power consumption by 15%. Similar to what other industries doing, KT is also putting effort on energy saving from IDC, as well as satisfying the customer needs. Air neuron is a global operator-based airflow prediction using dynamic zoning, probabilistic prediction enhancements, and computational fluid dynamics. KT aims to meet customer requests on temperature and humidity, while at the same time improving power usage effectiveness to the global top level. KT envisions new business opportunity out of these newfound ideas, and here is one use case example we have today. We have utilized artificial intelligence and machine learning together with energy saving, creating a new service called AI Building Management. It allows energy optimization from 380 facilities by auto-loading operation, fault detection, and suppression, indoor air pollution level. Our experience shows that per building energy OPEX has been reduced by 10% and productivity has increased by 20%. Please note that small building solution is being offered free of charge, as KT is committed to make Korea's energy saving policy work. So we had a chance to look at what KT is doing in decarbonization activities. We can clearly find the use cases from our peers around the world on their effort to achieve carbon neutrality by network energy savings. As I mentioned earlier, telecommunication technology has been focusing on improving performance, coverage, and mobility in the past. Now, telecommunication industry also is taking efforts on network energy saving from carbon-free environment. GSMA has been undergoing case studies on operators' efforts on energy efficiency. KT is deeply involved and actively engaged in these various global activities and fully committed for decarbonization, creating the better future. Concluding my presentation, I would like to emphasize that it's very important to share operators' use cases and best practices on decarbonization for synergy impacts across the board. I hope that we can collaborate on global scale to solve various issues presented on carbon neutrality and net zero. Once again, I would like to express great appreciation for having me on this stage and allowing me to present on this important topic today. Thank you, and hope the rest of the session provides more insights and depth on the matter.